I can describe each subset of the real number system and give examples and non examples. Vocabulary: terminating decimal. That is a decimal that comes to an end and stops. It does not go on forever. A repeating decimal is a decimal which has repeating digits or a repeating pattern of digits. These things are very important to understand. Just remember, terminate means stop, and repeat means it happens over and over in a pattern. So irrational numbers are all non repeating, non terminating decimals. The king of irrational numbers, or the queen, if you would like to, is pi. If you put pi, oops, I didn't mean to do that, but if you put pi in your calculator, it goes on forever and ever and never repeats any numbers or any pattern of numbers. The only reason it stops here is because my calculator ran out of room. Okay? So irrational numbers look and act like pi. They don't repeat and never stop. A non-example of this would be anything on the rational side, which we'll talk about. 2, 0, -5, and of course, decimals that stop or repeat. Now let's look down here. Rational numbers are all numbers that can be expressed as integral fractions. That means fractions whose denominator and numerator are integers, including terminating, which means stop, and repeating decimals. So there are a lot to say about rational numbers. First of all, if it can be written as a fraction, negative or positive, doesn't matter, it is rational, because eventually when you put in a fraction, its digits will either stop or repeat in a pattern. Another thing that you might want to think about is anything that has a decimal that stops, like 1.5, definitely rational. Anything that has a decimal like 0.3 with a repeating bar above it that goes on forever, 3, 3, 3, 3, 3, 3, 3, definitely rational. A non-example, best one, pi, because it's not any of these things. And also another example might be a messy square root, like the square root of 2 is going to go on forever. All right, so a rational number over here might be the square root of 4, or let's say the square root of 16, which is 4. And that is rational. But this square root over here that's very messy when you put it in your calculator, and let me show you, is irrational like pi. All right, so we're going to talk about the things below the label of rational. Remember, we said naughty weasels ignore rules. Well, the rules are the rational numbers, but the naughty weasels are the things we learned first in our life. 1, 2, 3, 4, 5. Whatever you learned how to count when you were little. Personally, I counted tacos. I love tacos. 1 taco, 2 tacos, 100 tacos, all of those taco things. I probably eat around at least 300 breakfast tacos a year because I eat one almost every morning for breakfast. Now, non-examples of natural numbers. That would be, so all of these over here are examples, and anything that's not right here on these points, these dots, are non-examples. So anything negative, any decimal, anything else is not natural. Now let's come up here and see that the only difference is the 0. So whole numbers are 0 plus every natural number. Okay? When they ask where the most specific place for 0 is, whole is where it goes. WHO for 0, LE. Non-examples of this would be any of your negative numbers, decimal numbers, anything that, because natural also fits into whole, but it's not the most specific for natural. It is the most specific for 0. Up here we have integers, which are all whole numbers, all of these, plus their opposites. -1 has 1, -2 has 2, 3 has -3. These integers are your perfect number line. So remember that when you think about integers, they are positive, they are negative, but they are perfect numbers with no decimals, and they go on a perfect number line. Okay? All right, now let's try some problems. This says, which sentence about rational numbers, so we're talking about rational numbers, is false? Okay, so we want the ones that are not true. First one, let's put it in the calculator. Negative square root of 289 is -17. Is that a rational number? It is. So that cannot be our answer. So let's put in the next one. 6 pi. Oh yeah, that's definitely not rational because it goes on forever. Basically, if something has pi involved, it's not rational. So this is going to be our answer because that's definitely false. But let's look at the next one. All integers are rational? Yes, they are, that perfect number line. And all whole numbers, including 0, are rational. They are also rational. All right, let's try the next one. Okay, this says, read the sentence below carefully and select the best answer from the choices. All right, we have a fraction. That means it is rational. Okay, if it can be written as a fraction and pi is not involved in that fraction, it is rational. We promise you that. Okay, because it is a fraction. That's the whole reason. -3/7 is a rational number because it's a fraction. Okay? All right, let's go on. That looks like the end.